Hey everyone, it's Adam. It's been a minute, but I recently made a Yield Aggregator DAPP, and I'm going to go over how to set it up and how to use it and how it works in this video. So what is that? At a high level, basically you can deposit money into Aave or Compound and earn yield or interest over time. And what this application does is that it checks and looks at which one is returning the better yield and automatically puts your money into, the more favorable one. And then it continually watches, and you can change it whenever you want and add more, whatever. So that's it at a high level. So this is used as Compound v3 and Aave v3. So let's get into it. So I'm going to just shrink myself here. So if you clone the repo from GitHub, you'll want to go into example.env here, and this is what it'll look like. So first, you'll want to get an Alchemy API key. So you can go to their website, make an account, set it up. So you don't want to put the entire URL in here, just the API key part. And then for private key, so this is just a wallet private key. So what this is that it's the first account in a hard hat local blockchain when you set it up. But we'll go over that. So that's what that note here is about. So you copy this, create a .env file, and remove this part, and then fill it out properly. And then you'll want to set up MetaMask. So I'll show you that here. So this is what the application will look like. We'll get into that later. So we open MetaMask, and you want to add the localhost network if you haven't done that before. So you go to add networks, and then go to networks, and then you would, click add a network, and then put in this information here. I already did, but that's what it looks like. And then if you're going to follow along, you'll want to add this account in. So you go to import accounts here, and then you'll want to copy this private key into it. So once you got all that set up, you can open up your terminal. So after you clone the repo, you want to have 3 terminals open. And then you want to go into depth yield aggregator, like the root directory of the project, and then npm install if you're doing it for the first time. I already did that, so I'm going to run npx hardhat node in the first terminal. So what this does is that it's actually forking mainnet and making a copy of Ethereum mainnet, and I'm running it locally in my machine. So that's where this account comes from. So these are dummy accounts with some fake ETH already in the accounts that you can use. So in another terminal, you want to run the deploy script. So that's npx hardhat run localhost scripts deploy.js. So that's what it should look like. So you run that and wait for the contract to deploy. All right, so contract's deployed. So I put this here to make sure that the fork is working. If you're seeing like single-digit numbers, it didn't work properly. But next, we actually want to get WETH. So this project uses WETH. So we'll go. So I wrote another script, which is get WETH.js. And that will just turn some of the ETH or the dummy ETH into WETH. And the the account that we're using. And then once that's done, you'll want to cd or change directory and go into the front end. And then you want to do npm install again. And then when you run that, or you're going to run that if you're doing that for the first time again. But I already did that, so I'm going to do npm start. Wait for that to boot up. All right, so I'll just refresh for good measure. So it should be on localhost 3000. And then I think are we connected? Yeah. So this is the ETH balance here, and that's the account. And then we can see the WETH balance is 100. That was from our get WETH script that we ran. So we're going to get started. I'll show you how it works. Also, it shows the compound APY and the Aave APY. So because of that, it should go to Aave when we deposit. So I'll just put in 10. So that's 10 WETH. So first we need to approve. So I'm just going to put 10. Hit next. Approve. And then we'll wait for that to, we'll see what the chain's doing. So there we go. Oh. And then we're gonna hit confirm. Might take a few minutes. All right, so it went through. So you can see the active protocol. So this is Aave. You can copy and paste this into Etherscan and see it. So our WETH balance decreased and the amount deposited is 10 into the aggregator. And then we can also withdraw. And then hit confirm. That's it. I'm still thinking. There we go. So we got our balance back and a little bit extra. And then you can also rebalance. I guess I can demo that as well. So we'll deposit 10 back in. It won't do anything though, because the yield in Aave is higher, so nothing should change. So yeah, we've deposited 10, and then we'll rebalance. So this checks, or like tells, this tells you to like, yeah, recheck who's got the better yield and put the money there, basically. But the money shouldn't move. Yeah. All right, so that at a high level is how it works. And now we're going to jump into the code. All right, so we're going to start with the contract. This isn't going to be super in depth, but this is basically how it works. We'll start with the deposit function. So it takes in 3 inputs, the amount. So that's, you know, just the 10 WETH that we put in when I was demoing the UI. And then it also takes in the comp APY and the Aave APY. So there's some stuff happening in the background on the front end. So this is a external function. So like only the owner can call this function basically. And then so it checks you're not trying to send nothing. And then if the amount deposited is more, so if you have already put in money in the past, then it'll call the rebalance function. So that takes in the comp and Aave APY as well. Then it takes in the WETH. So it takes WETH from your account and then puts into this contract basically, and then deposit amount. So basically figures out, or this updates the amount deposited in the contract, and then checks the APY. So this is just like an if else statement to calculate the APY to see where if it should be deposited to Compound or Aave. So we'll check out the deposit to Aave function and how that works. So it first gets the Aave pool from this function here. And basically the reason for that, I guess the Aave pool address can change in the future. So it uses this address. This address does not change. So this like contract, basically its only job is to return the correct address so for where the money can go. So in the documentation talks about the get pool function, and that's how that works. So it gets the Aave pool, and then so it approves your WETH, and then checks, and then so this is the function of the Aave pool of the address that we got. So it's .supply. So this is the function that you call if you want to deposit into the Aave protocol. So it takes in the ERC20 address. So in our case, it's WETH, and the amount, and then the address of this contract. So that's like who's sending the amounts. And then this is, I think, just like a promo code thing. So we're leaving it 0 in this case. And then it just updates the location of funds. So it says, hey, your funds went to Aave. And then for a deposit compound, pretty similar. So it approves the WETH and then comment supply. So this is basically Compound. They have like kind of like another contract that manages the protocol. So this is how it works for them if you read their documentation. And then it just updates the location of funds. So for the withdraw function, it first checks to see if there's any deposited already. And then it does like an if else statement and basically checks the location of funds. So if it's in Compound, then it will withdraw from Compound and then transfers the WETH and updates the location. Same for Aave basically. So let's look at the withdraw functions. So this one's private, so it can only be called. So this function can only call this function. The owner of the contract can't, or nobody can. So how that works. So if you want to withdraw from Compound, it uses the Compound contract. So the contract has a withdrawal function. Takes in the WETH address and the balance, and then basically returns the WETH balance of this address. And then for withdraw, it's basically the same, but for Aave, we need to get the pool first. And because the Aave pool address can change in the future, we have to just double check that we approve that Aave pool. And yeah, so then we called the withdraw function. I don't totally remember how this works, but it explains in the documentation. And then it just updates the balance of this address, or the WETH balance of this address. So yeah, that's the withdraws. So once it withdraws, it emits the withdraw event and then updates the deposit amount. And then we'll go to rebalance. So rebalance takes in the comp APY and the Aave APY, and then basically checks that you've already deposited, and then gets the Aave address, and then we have like an if else statement here. So basically what this checks for is, you know, who has the higher APY and the location of funds. So if it's not in compound and the APY in compound is greater, it will withdraw from Aave and the deposit to compound and update the location of funds. And basically same thing happens here. So it checks that, and then withdraws from compound, deposits compound, and then updates the location. And then once the rebalance is done, it emits a rebalance event. So for the getter functions, I called this where balance. So this tells you where your balance is. So it just tells you, or returns the location of funds here. So it'll give you the address of where your funds went, and then the deposit balance. So same variable type thing. Just tells you the amount, the total amount that you've deposited. So that's the contract. So we'll head over to the tests. So first, you know, initializes some accounts for us to use. So the first one's owner, so the person who like deployed the contract and owns the contract, and then user, which is just someone else, and then basically deploys the aggregator contract, and then gets some other contract instances. So this is the WETH contract, the comment. So this is the compound contract, and this is CWETH. So you actually get CWETH from compound when you deposit. And then the Aave contract. So this test actually does something. It doesn't just test, but it also checks that it worked. So this is like the code that gets you WETH. That's also in the get WETH deploy script. It's pretty similar. And then yeah, so it expects that you actually got WETH. And then this checks for the API, there calls the APY rates. So this actually takes in, you know, the contracts. So we'll go into how that works into the APY. So it takes in the compound WETH contract. So a lot of this is basically explained in the, you know, the documentation of basically how to do it. But it, like, you know, at a high level, it calls a function in the contract. So get utilization, and then gets the supply rate. So you add the utilization into there, and then does the math, and then returns the APY. And then same thing for Aave. Aave is a bit different. So you take in like the Aave contract. So you have to actually use like actual WETH, seconds per year. So basically it kind of does, you know, math computations to figure out the Aave API, but it's in the documentation. It's pretty complicated. But basically the main takeaway is that a lot of it is done off chain, and you have to do it locally in the front end or what have you. So back to the test. So text to make sure that it doesn't equal 0. And when I was figuring it out, it was actually pretty easy to get a 0 response. So I thought that was a good check to do. So for deposits, what's going on here? Oh yeah, so it gets the comp and Aave APY. And then, so we just approve the WETH or 10 WETH right off the bat. And then for deposit, so for this, the way I had helpers set it up, actually it's this part here. How I had helpers set it up is that it actually returned, like 2.7 or whatever. So if it was 2.7% APY, it would say 2.7, but in Solidity, you need like whole numbers. So I basically just like rounded it to like, the whole number, and then times it by 100. So Solidity can understand it. And then, so it tracks the balance. So it just makes sure that once you deposit the amount that the balance is 10, or that you did, or the balance is updated correctly. And then tracks WETH. So it checks that it went to the right place, or actually it just console logs it. So if I ran the test actually, so I'll do npx hard hat test. Wait, did I? Yeah. Oh no, it's a test, so it's okay. Man, it's slow. I guess it's got fork mainnet. So it'll basically return where it came from. So then it checks for the deposit event was emitted. So then it checks to see if you didn't approve the WETH, that it would be rejected. And then, so this checks for withdraws. So it gets the APY again, and then we approve the WETH. Then we deposit 10 ETH into the contract, and then we call the withdraw function here. So we're checking the event here, so it gets the receipt, and then it what this does is that it like scans through all the events to see if there was a withdrawal, and then if not, it'll say no events were emitted if it didn't find any. And then, so updates the user contract balance. So after we call withdraw, the balance should be 0. And then fails if another user attempts to withdraw. So if someone, if it's the user, like it's just somebody else, then it'll fail. And then for rebalance, we get the comp APY and Aave APY, and then we approve the WETH, and then emits rebalance event. So basically, pretty similar to what happened up here, just checks to see if there is a rebalance event, and just scans through all the events. And then fails if owner has no deposit amount. Fails if owner has no deposit amount. Yeah, so it'll fail if there's no balance in the contract and you try to rebalance, it won't work. All right, so now we're going to head over to the front end. So that's, why is this open? So source, actually we'll start at, we'll go to index.js, or no, nothing really going on there. So basically this updates, the state to get the blockchain or get blockchain data. So that is in commons. Where's that? So that's in utilities and commons. So basically, it checks to see if MetaMask is present and then requests the accounts. And then this basically gets the, the aggregator contract here. And gets the, the signer and stuff. So that happens here. So that's basically like all the blockchain data gets passed in. So we have the nav bar. So these are the two components. So go to nav bar, and this basically, connects the account. So we have the connect handler. So if we press the, the connect button, initiates the connect handler here. So it tries to request and then, gets the account, the proper account. And then if accounts change, it basically will update the UI for the new account that's changed. And then for the aggregator, all right, so for the main bit, so these are all the hooks. So it uses, these uses all state or use state hooks. And then, so use effects, so it automatically, so this runs as soon as the app is open, and then updates these variables here, and then sets it to the state. So that's how, the balance, the APY is shown in the front end, because it's updated down here. So it gets the APY or the Aave APY variable because it sets it here. Let's see, set Aave APY from using the use state hook, for example. So that's kind of like how all these work. And then these are just, the addresses that it needs. So some other things is that it creates or upcreates new contracts. So it has like, the contracts that it needs. This is a lot of the same stuff in the test that I explained. It's a lot of the same code. So when you press the buttons, it runs these functions. So when you press the deposit function, it runs deposit to aggregator. So it takes in, the input. So what this is when like you put in 10, this is what makes it so you can just put in like 10, not 10, and not like you don't have to put in the way amount. And then this is so it waits for you to approve the ETH. So like in MetaMask, so we approved it first, and then it'll wait, and then it'll call deposit. So it connects to the signer and then calls the deposit function. And then this is, just the Aave APY calculations and then updated so Solidity is happy, and then waits for that to happen. And then if something goes wrong, it shows the error and tells you why. And then withdraw gets the blockchain.aggregator, or calls the connect, or connects the signer, and then calls the withdraw function of the aggregator contract, and then waits for it to call, or waits for it to be completed, and then rebalance. So this is a lot of the same stuff. So this is just the aggregator contract, calls the rebalance function, and then you put in the APY in a way that Solidity can understand, and that's basically the front end for the aggregator contract. And then after that is the scripts, and then I guess the hard hat config. So go into the hard hat config. So this is basically how I'm able to fork mainnet, and this is why you need an Alchemy API key, because hard hat forks mainnet, so you can use everything that's on mainnet locally, do tests and try things out. And then this is the deploy script. So this is nothing really fancy here. It's basically pretty close to the default settings. But this is, I'm really excited about this. So this is the magical code that links your contract to your front end. So this uses the file system, or the Node.js file system to update files and stuff on your computer. So for ABIs, it updates this and puts the contract by default, or right away. How do I get back to where I was? I was in deploy. Deploy.js. So yeah, you can use this code if you want. It gets called here. Basically, if you want to use it yourself, you would update basically everywhere it says aggregator, and if it's a capital A, put a capital letter or lowercase or whatever. And then we have, what else? Where's scripts? Scripts. So this is just we're pretty similar to what was in the test, basically. So this is what gets you the WETH when you deploy it. So yeah, that's the Yield Aggregator DAPP application. You can take it and you can deploy it to other, layer 2s and stuff like that, or you can add to it. And yeah, thanks for watching.